So today we'll be trying out question number 1 of ISC 2012, and it's based on prime as well as palindrome. So a prime palindrome integer is a positive integer without leading zeros, which is prime as well as a palindrome. Given two positive integers m and n, where m is less than n, they have given that m is less than n. Write a program to determine how many prime palindromes integers are there in the range between m and n, both inclusive, and output them, right? And then they are saying that there is a range that is m and n should be less than 3000. Okay, so the program seems to be quite straightforward. There are two places where we can perform optimization. One is obviously in the prime and the other is in palindrome, and also in the order in which we call them. So let's start and then we'll see how and when to perform those optimizations. Any doubts in the question itself?
No, sir.
No. Okay, your volume is a bit low. If you can increase it somehow.
So it is fine now?
Okay, no problem. I'm able to hear. So let's begin. So what we'll do is I already have a template ready. So let's start. So the first thing is input, and we have to enter two things, m and n. So I'll say that okay, int m is equal to in dot next int. That will take the first number, but before that we have to say that m equals 2. And then that is to be followed by n is equal to. So again I'll copy the prompt, paste it in the next line, and then we'll say we have to remove that caption input from there, and m will become n here as well as in next line as well. So this becomes n. So now our input is done. The next step is to check the range. So they are saying that the range is from up to up to 3000 only. They are not checking for the lower limit as such, right? So let's begin. We'll say that if m is less than 3000 and n is less than 3000, if it is in limits, we'll proceed normally, else we'll display the error message. So no, I thought that it is in the clipboard, but it's not in the clipboard, so I'll just type it out. System.out.print ln, and we'll say output :/t, and the exact message was out of range, right? So I'll just copy out of range and we'll paste out of range over here. So this takes care of the condition part. Now if we are reaching till this stage, the range is correct. Any doubts in that?
No, sir.
Okay, if the range is correct, now we need to check prime palindrome, and since we usually write, not usually, we almost always write fully object oriented program, so we'll take a separate class. We'll call it prime palindrome, and within the prime palindrome class we'll have our private data members, and those private data members are m and n. Then we'll have our constructor to initialize the instance variable m and n, so we'll call it prime palindrome, and we'll take int m comma int n. And the next step is obviously we have to store, so this dot m is equal to m, this dot n is equal to n. So the variables are stored, and now what we need to do is we need two functions, one for prime, one for palindrome. So let's make those two functions. Now these functions will be called from within the class, so we'll make it private. So we'll say private static boolean is prime, and let's say the argument parameter is n. We want to check whether n is prime or not, and though we can do the counting stuff, that is count the number of factors, check it against 2, but we already know that that is not a very good way of doing it. So the better way of doing it is requires slightly more typing, but we'll do that. So let's begin. So we'll say that if n is less than 2, it is not a prime number. We'll say return false. if n is equal to 2, 2 is the only even prime number, so we are making a check separately for the same, and then we'll say return true. If we are reaching this line and n is even, it cannot be a prime number. Why? Because 2 is the only even prime number, right? So we'll say if n modulus 2 equals 0, we'll say return false. Now, if we reach till this else, the number is odd and it may or may not be prime. So now what we'll do, we'll take a loop. In order to avoid repeated factors, we'll just take the loop till the square root of the number, math.sqrtn. And then since the number is not 2, we'll start the division from 3. We'll take the loop up to limit, and since the numbers are only odd, we will not divide by even numbers. That is, we'll increase in steps of 2. So I'll say int divisor is equal to 3, divisor is less than equal to limit, and then we'll say divisor plus is equal to 2. So we are not starting from 2, 1, we are not going till the number. If there is any divisor, it has to be the third factor, which means that it's not a prime. So if n modulus divisor equals 0, we'll say return false. And if the loop completes without finding any divisor, we'll simply say return true. Any doubts in this, Milan?
No, sir.
No.
It's clear.
Okay, so this take cares of the prime part. Now we come to the palindrome part. Now palindrome means that the number will be equal to the reverse of the number, and many students usually prefer to first reverse the number and then check. So that is what we'll be doing, because this is not a string. So we cannot perform optimization to that part. Is that okay with you?
Yes, sir.
So private static boolean, and we'll say is palindrome, and let's say the number which we want to check is n. So we want to check whether n is a palindrome or not. So what we'll do now is
Sir?
we have to reverse. You're saying something?
Yes, sir.
Yes.
So I wanted to ask that just like in strings, why can't we like divide it by 10 and mod it by 10, like separate out the first and last digits and check for equality?
And then do what?
So if it is not equal, like then we can break out anywhere we want.
So the thing is, you are actually doing more work, isn't it? Division and modulus, then again comparison, then again division and modulus to strike them out. So it's actually more work. What do you say? Right? We are trying to make it efficient. I mean, we can but that makes more sense for string. Like for example, if you are checking a string for a palindrome, you can go for a recursive approach. That makes it neat. But here in the case of integer, that's not going to help. Okay, so we'll say int temp is equal to n, while temp is more than 0, temp divided by is equal to 10. And then we'll say reverse is equal to reverse into 10 plus the last digit of temp. So temp modulus 10. So this will reverse the number, right? And once it is reversed, we'll go out and we'll check. We'll say return. No need for an if also, because if the condition evaluates to true, it is palindrome, otherwise it's not a palindrome. So if n equals the reverse of n, it is a palindrome. Any doubts in this?
No, sir.
Okay. Now what they were saying in this question is that we have to check whether we have to display all the prime palindromes within a range. So we have already initialized, no, we haven't done it. So now let us create an object. We'll say prime palindrome, and let's call it something. What to call it? Obj? Obj is equal to new prime palindrome. Wait, prime palindrome, and then we'll pass m and n. So object is created. And then we have to prompt again display a message. We'll say system.out.print ln, and the message is output :/t, and then we'll copy the remaining message, and the remaining message is the prime palindromes are. I'll copy it from there, I'll paste it over here, so the message is displayed, the line has been changed, and we need a /t at the next line, so we'll say /t also. And now, like we always do, we'll like to directly print the object system.out.println obj. Now, since we are trying to convert obj into a string, computer will look for a function by the name of
toString. A string function like
a
toString
string
function.
function by the name toString. So we'll override toString so that when system.out.println obj is said, this will be triggered. Now here we'll have to print, but please understand we have to print only. Even though we can find and print over here, that's not a good idea, because if someone decides to print it many times, why should it be run several times? So what we'll do, we'll use a better approach, and that is we'll take a string instance variable, we'll call it output. In the constructor, we'll say output is equal to nothing, or not even in the constructor. We'll just make a function process. So we'll call the function by the name of process. And then obviously we have to define the function process. So we'll go over here and we'll say public. Yes, what should be the type? Public void.
Void.
Should it be static or it shouldn't be static? No static. No need for static. Public void process. And within this process, we'll populate our output variable. So we'll just say output is equal to nothing, and that will be followed by all the tasks which is to be done. So what we are supposed to do now, we are supposed to take a loop. So we'll say int n is equal to, we'll start it, no, we can't say n because n is already one of the variables. We have to take a loop from m to n. So let's make it a bit descriptive by saying number is equal to m. We'll start from m, we'll move till number is less than or equal to n, because it said both inclusive, and then we'll say number plus plus. Okay, now we have to check if it is prime as well as palindrome, and what should be the order? Should we check prime first or should we check palindrome first? We should check the least expensive one first. Okay, because we have seen that finding prime requires considerable effort compared to checking for palindrome, isn't it? So we'll check for palindrome. If it is a palindrome, then we'll check for prime, thereby saving a lot of time. What do you say? Otherwise, square root has to be found and other things might be come into play.
Yes, sir. So I would also suggest that like we can ignore the even numbers also here.
Where?
So in this.
Oh yes, that's a nice idea. So if you have to ignore the even number, then what you have to do?
So if we can check initially that if m is already even, then we can just do it +2.
Okay, so you are saying that if m modulus 2 is equal to 0, if it is even, then what you want to do? If it is even, then m plus 1.
No, yes, sir. It is if it is even, then we will do m plus 1. We'll start checking.
Otherwise, it will remain m. And then you are saying we'll say plus is equal to 2. That's a very nice idea. So now it will run even faster. Clear? Okay. Yes. So if is palindrome number, that's the first part, and is prime number, if both of these are there, then we'll add it to the answer and we'll say output plus is equal to number plus a comma followed by a space. Now the problem with this approach is that there will be an extra comma and space after the last element, and there is no comma and space after the last element, so we have to get rid of that once the loop is over. So once the loop is over here, we'll say output is equal to output dot substring. We'll take everything from the 0th character, but we'll stop 2 characters before. So we'll say output dot length minus 2. Make sense? So that will get rid of the last part. And then here we'll say,
Sir,
we have to do one more thing, I remember. Let me say return output first, return output. Yes, what you were saying.
so in the loop, in the process function, you have like in the increment function, you have written two pluses.
Yeah.
You have typed.
Okay. There is one more task which is left, and that is the frequency, isn't it? So we'll create one more variable for the frequency over here, right? And the best way to find the frequency is that while you are processing it, we'll find the frequency as well. So initially, frequency will be equal to 0, right? And whenever we are having the number, we'll say frequency plus plus. So that will take care of the frequency. And we should also have one more function to return the frequency. So we'll say public int get frequency. Oops, sorry, the spelling, get frequency. So this will fetch the frequency, return frequency. Okay, so we come down. We have already displayed the prime palindromes are. Now we are supposed to display the frequency, and that is supposed to be preceded by a tab character. So we'll go over here. We'll say system.out.println. We'll copy paste the message. We'll prepend a /t. This was not there in the original question. I'll get rid of it. And then here we'll say obj.get frequency. So hopefully our program should work now. What do you say? Should we run it?
Yes, sir.
Okay, the first test case given was 100 and 1000. So let's run the program. So 100, 1000. Output the prime palindrome integers are this 15. We forgot a tab over here that we'll add. Otherwise it's okay. Other than this tab character, there's one extra space over here, right? So let's take care of those two things. So we come over here where we are initializing output. We'll say that we want a leading tab. Okay, or is it a good idea to place a tab over there, or we should add a tab where we are actually printing it? Here, what do you believe? What is better?
So we can add a tab where we are printing it.
Actually, we are supposed to say over here /n/t, isn't it? This shouldn't be ln. That was already there, but we goofed it up a bit. Okay, so now that will take care of the first problem, and the second problem was the prime palindrome. There's an extra space. We get rid of the space. Okay, let's run it once more. So 100 and 1000 is the input. So this is 100. The next input is 1000, and there we are. Frequency is 15, and the next case is obviously going to run 100 and 5000. 5000 is out of range. So let's run it once more. 100 and 5000 out of range. Any doubts?
No, sir.
Okay. So in the next class, we'll be doing question number 2.
Thank you, sir.
Okay, thank you.